Today, let's look at this graph theory question. Suppose G is a simple graph containing odd vertices. Prove that there exist two vertices x and y such that the number of common neighbors of x and y is even. Now, first of all, we need to understand what is the meaning of this question. Let's look at an example of G containing some odd vertices. Suppose this is a graph G that contains some odd vertices. Let us label the degree of each vertex. And we may label the vertex as A, B, C, D, and E. And in this case, we'll see that the neighbor of A is actually equal to B, D, and E. B, D, and E. And the neighbor of C are B and D. So in this case, the common neighbor of A and C are B and D. And therefore, in this case, A and C has two common neighbors. And this A and C is actually one possible pair of x and y in the question. So this is just an example on 5 vertices and with specific degrees. So how are we going to deal with this for general graph?
Pause the video now if you wish to solve it. Keep watching the video once ready.
So we first let x be an odd vertex in G, since it said that G contains some odd vertices. Now let's consider the induced subgraph by the vertices of neighbors of x. So this is x, and the degree of x is an odd number. So this will be the neighbor of x. So when we consider induced subgraph of nx, so this is a subgraph that we are going to consider. Call this subgraph as h. So the number of vertices in h is an odd number. And it means that there exists a y here such that the degree of y in h is even. Otherwise, we'll have odd numbers of odd vertices in h, which contradict to the handshaking lemma. If you enjoyed this video, please like, comment, and subscribe. Let's say this is a y, and this y is of even degree in the subgraph nx. So it means that it will have even common neighbors with x. Now note that there is possibly that y also join other vertices in G but not in H. But that's fine, because what we want to consider is only the neighbors that we find in H. And therefore, now we know that the common neighbor of x and y is even. And this proves the statement here. That's all for today's lesson. I'll see you again next time. Bye bye.